Well, hello, my name is Kang Fan, and this is my Fluent project for uh, Ozbay. This is my first project, and today I am doing case A, was it flow? The rest of my group is gonna do the B and the C. So to begin, let's start with doing the the setup. So first, of course, you install the analyst workbench, and I went to geometry right here and basically right clicked and went into the fluid flow simulation, which is right here. Um, and then I clicked on the Z plane. Next thing you do, I'm going to start my sketch, go sketching, and then get a rectangle. I'm doing a rectangle. There we go. And then now you set the dimensions for the thing. Okay, now I need the horizontal and vertical dimensions, which are smart dimensions. So let's first do the horizontal and then the vertical too. There we go. I'm gonna go up here and change my units to millimeters. So there we go. Units are in millimeters. Yep. And I'm going to change the values, which I can go over here. Go to details view. In the assignment, it said to use the different one from the video. So basically, what I'm going to do is instead of doing the 510 like the video said, it says to do L is equal to 150 H. So I think I'm gonna do um, 2 millimeters for the height and 300 millimeters for the length. So in the instructions, it said to do L is equal to 150, so the length, it should be opposite. It should be the length is, the height is 2 and the length is 300. So H1 should be 300 and B2 should be 2. And that should give us a good long rectangle, as you can see right here. There you go. Now I'm going to select these so these are out of here. There you go. Now I have a surface. I have a green check mark for geometry. And now I double click on the mesh and I get this screen. Yeah, this screen. This other screen's for the other one. And now we got our body. So I'm going to go to the edge, create name section. This is the upper wall. inlets, and outlets over here. Outlets over here. I'm going to select the upper and lower wall, apply, which should give me this. Um, let's do it by 2500 divisions, which should give us a good, change this to know what that is. Set this to no. Behavior should be hard. Um, no bias. Number of divisions. Good, good. Now two edges. Now I'm going to generate the mesh. And I'm back. So now we click up here. Now you can see all the mesh. Yes, looking great. Now I need to do the same thing for the inlet and outlet, which will take long. So let's insert sizing, right? Yes. And do the two edges. Change the number of divisions. Um, let's do it at 50 divisions. Change the temperature to no. And change the behavior from soft to hard. Now we generate this. Should take a while. And the meshing is ready. And now select base meshing. Apply. No, yes. Quadrihedral. No, no selection, no selection. Why does this happen? No, no generate. Now zoom in. See the whole mesh. There we go. Looks great. Let's click A. Graph. Now I'm gonna go back to the workbench. Right click. Update. We got a green check mark, which is good. Now we are on the setup. And now I double click setup. After I get this, model, viscous to laminar, because that's the flow we're doing. Now we go to residuals and do all these values. So we do have viscous laminar now. Do these all to 1 to the e to the negative 6. Okay, now we go viscous laminar. Now go to materials. Change the density to 1. Oh, so let's choose our own density for air. Um, because that's what it says in the assignments, I believe. Uh, let's see. Let's choose a viscosity. Let's keep the density at 1 for air. And let's choose the viscosity as 1 to the e minus 5. So then the Reynolds number can stay below 2,500. Um, Actually, for viscosity, let's choose a different, and we should have this quickly. There you go. Okay, it does have air selected. Go down here to reference values, shoot from inlets. Okay, this is right. Everything updated. Reference zone should be surface body. Let's look at the dimensions. Okay, let's change variables under boundary conditions. Okay, for Bell, we want the inlet velocity. So that's what I'm going to do, right? I have percent. Yes, I do have percent flow. So let's start with the inlet velocity. My velocity, let's just change it to 10 meters per second. Um, it says to choose your own in the assignment, so I should not be copying from the video. Right, let's see. Just making sure real quick. Yes, use any velocity. So let's choose the velocity magnitude to be 10, because why not? Okay, outlet pressure. The only thing we're gonna change is to put reverse flow if I can get it in right here. That's it. And reverse flow. Close. Check the walls. Make sure they are stationary. So let's see, stationary wall, as you can see. We'll check the upper wall, stationary too. Oh, with no slip connection. Nice and nice. Close, close. Now go to reference values. I'm just gonna double check. These look great. Velocity, wait, velocity should be 10, right? Or is it inlet velocity should be 10? What is this? No? Okay, yeah, it is 10. Fly, close, go down, and then initialize. Initialize. There we go. Here's our initialization. Now we're just gonna run the calculation. Double click it. 250 alliterations. Like, and as you can see, the graph slowly declining. Calculation is complete. Now we go to workbench and go to results, solutions done. The speed axis, go to location, and let's insert some lines. First line should be the M line, which is the midline. It I did 300, so it should be 150. So it should be 2.15. Zero. Y should be 0.02. Oh, because it's in milliliters. I mean, millimeters. Hmm, hit apply. Now we're gonna add our end line. E1. This case, we should go right before the end of the system. I did 300, so it should be 0.2999. And it should be 0.2999 over here too. this is the height, so it should start from 0 to 0.002 because I did 2 millimeters. 100 samples to make the line good. Line, and we can see the line right there. And then we also add the developing flow line. So let's change this to developing flow. And we kind of want it to be like near over here a bit. So let's just do like, I don't know, let's do 0.0. It should be like a little bit after the initial point. So let's just do, I have 300, let's just do like 10. So let's do 0.01001, actually, because that is like a little bit after for the developing flow. And of course, here's the height and 100 samples to make it thicker and apply. So this is good right here. We can also change it later. So now we're going to generate a contour. Uh, can generate a contour. Let's call it just contour 1. Let's do symmetry 1. Velocity u for the variable. And let's set the number of contours 110. And then let's apply. The legend's kind of in the way, so let's change that. First thing you do, I'll go to default legend view, horizontal, scientific to fixed, apply. There we go, looks a little bit better. Now let's go into our charts. Go into our chart, insert chart. Change the title to velocity profile, or Poiseuille flow, because that's the flow we have. How do I spell Poiseuille? Let's just copy it over here. Um, and let's go data series, change it the location to midline, and the name to midline too. Get another line too, inline, location is inline, and then the last one is the developing flow. Developing flow line, and let's notifications here, and then let's apply. So we see three lines. Now let's go to the variables. There's the x-axis, x is velocity u, because we want to see the velocity. This should be y, variable y, y-axis for y, then let's apply. So here's how Poiseuille flow. Now this is the graph of the velocity profile for Poiseuille flow. Now you see how this green line overlaps over here and over here. So that is it. I'm just going to export it, and that is the lab for Poiseuille flow. Um, thank you for watching Ozbay um, or the TA. Hope you liked the video. I tried my best. And yeah, thank you for spending the time to watch this video. Bye.